Welcome to The Explainer. Today, we are cracking open the machine learning toolkit to really understand the powerful algorithms that are reshaping pretty much everything in business. Let's get right into it.
So, have you ever stopped to wonder how Netflix just knows what you'll want to watch next? Or how your email inbox is, miraculously free of spam? We see these things happen every day, and honestly, they can feel a little bit like magic.
But of course, the answer isn't magic. It's actually a super powerful toolkit of algorithms. The best way to think about it is like a master craftsman's workshop. You've got different tools for different jobs. Some are for sorting, others are for predicting, and some are really specialized. Today, we're going to explore some of the most important ones.
Okay, first up, let's dig into the sorting tools. These are the ones you pull out when you're faced with just a mountain of raw, unlabeled data. You use these when you don't even know what you're looking for, but you're trying to find some kind of hidden structure.
Yeah, this quote absolutely nails it. Imagine you've got this overwhelming amount of information, right? How do you possibly boil it all down to its most essential parts without losing the main point?
Well, that is exactly where something called principal component analysis, or PCA for short, comes into play. It's a fantastic tool for pre-processing your data because it's designed to simplify complexity. It takes a whole bunch of related variables and intelligently combines them into just a few much more meaningful components.
And here's a really practical example of just how powerful this is. Instead of a bank trying to juggle, 22 different variables for a single loan applicant, PCA can boil all of that down into 4 clear, understandable themes. All of a sudden, something that was super complex becomes clear. You get the big picture without drowning in the details.
All right, so PCA is great for simplifying things. But what if your problem is different? What if you need to find natural groups in your data from the ground up? For instance, how do you segment your customers when you don't have any predefined categories to start with?
Well, for that job, we grab a tool called K-means clustering. This thing is brilliant for tasks like market segmentation. It just looks at all your data points, say all your different customer behaviors, and starts grouping the similar ones together, often revealing these distinct customer profiles you never even knew existed. And how it works is actually pretty cool and, really logical. First, you decide how many groups, that's your K, you think are in your data. Then the algorithm just kind of plunks down some starting points, the centroids. Then every single one of your data points gets assigned to the closest centroid. After that, the algorithm looks at all the points in a group and moves the centroid to the new center. And it just keeps doing that. Assign, update, over and over until the groups are stable and don't change anymore. Simple, right? But incredibly effective.
Okay, so we've sorted our data. Now, let's switch trays in our toolkit and move on to prediction. This next set of tools belongs to what we call supervised learning, where we use labeled historical data to help us forecast what's going to happen next.
I mean, this is the question in business, isn't it? Predicting what's coming is absolutely critical for everything from setting budgets to managing inventory. And our next tool has been the go-to for this for a long, long time. And for that, we meet an old friend, linear regression. This is a true workhorse in the world of data science. It basically works by finding a simple, straight-line relationship between variables. So it can help you predict things like how much a used car is worth based on its mileage, or even how many people might visit a zoo based on the weather. And don't let its simplicity fool you. The results can be amazingly precise. Just look at this. By crunching the numbers, this model figured out that for every single 1 degree Celsius increase in DC, bike rentals dropped by more than 92. That's not just a vague trend. That's a specific, actionable number you can build a strategy around. But what happens when you're not trying to predict a number, but a choice? A simple yes or no, accept or reject. For that kind of problem, we use a decision tree. It works exactly like a flowchart, asking a series of simple questions to lead you down a path to a final outcome. What's so great about a decision tree is that its logic is completely transparent. You can literally follow the path down the branches to see exactly how it reached its conclusion. And this is its superpower. See, a lot of other more complex models can feel like a black box. You put data in, you get an answer out, but you don't really know why. In fields like banking, you have to be able to explain why someone was denied a loan. That's where the clarity of a decision tree isn't just nice to have, it's essential. All right, let's head over to the specialists corner of our workshop. These are the highly focused, custom-built tools for very specific jobs that, believe it or not, you probably interact with every single day.
Remember that Netflix question from the very beginning? Well, this is the heart of the problem for any streaming service or online store.
How in the world do you recommend the perfect thing when you have millions of users and millions of options?
The secret sauce here is something called collaborative filtering, and it's so clever. It doesn't really care about the movie itself, the actors, the genre, none of that. It cares about you. It looks for other people out there who have the same taste as you. Then it says, hey, these people who love all the same weird sci-fi movies you do also love this other movie you haven't seen yet. You'll probably love it too. It's literally like getting a recommendation from thousands of your cinematic soulmates.
Okay, so we've looked at tools for sorting, tools for predicting, and these highly specialized tools. We've got this amazing toolkit. But how do you pick the right one for the job?
And this, right here, is maybe the most important takeaway of all. The algorithm itself is secondary. What really matters is having a rock-solid, crystal-clear understanding of the business problem you are actually trying to solve. Get that right first. So let's put it all together in a quick cheat sheet. If your job is to simplify a ton of data, you're going to reach for PCA. If you need to find natural groups or segments, K-means is your tool. Predicting a specific number, that's a classic job for linear regression. When you need to make a classification and explain why, the decision tree is your best friend. And of course, for making recommendations, it's all about collaborative filtering. It's always about the right tool for the right job.
And that brings us to one final big picture question. You know, as this toolkit gets more and more powerful and easier for everyone to use, that line between a machine helping a human make a decision and the machine making the decision itself, well, it's getting really blurry. So the question for all of us is shifting from what can we automate to what should we automate?